Page 33, number 162. Triangle ABC is rotated 180 degrees around point P, 0, 0. Select all the true statements below. Now it says the triangle ABC, but we have no triangle graphed and we have no coordinates. So in a situation like this, I provided a graph for you because you should try any triangle and go through the motions, rotate it 180 degrees, and see which of the statements would be true. Since it does not specify the triangle, make your own. So I'm going to go to my visual here, my graph, and I'm going to make up a triangle. Now, I like to use right triangles. I think that they're very helpful in case I need to solve for a missing side length or an angle. I know that right triangles are able to use trig or Pythagorean theorem, so I like to use right triangles. You pick whatever you want. You can put it wherever you want, but I'm going to put it in the first quadrant. So I'm going to put a point at 1, 6, at 1, 1, and then at 6, 1. Actually, let's do it at a little shorter. Let's do it at 5, 1. I'm going to label this A, B, and C. Okay, so it said it rotates 180 degrees. So in other words, it's going to go upside down. You can physically turn your paper upside down and write down the coordinates and then graph them. Or you could use the rule that we previously talked about. Change the sign of X and Y. So the B value, which is at 1, 1, is now going to go to -1, -1. So it's going to go here. That's your B prime. C is at 5, 1, so now it's going to be at -5, -1. And lastly, it's C prime. And lastly, A is at 1, 6, so I'm going to put it at -1, -6. A prime. So here is my rotated 180 degree triangle. Now I'm going to go through each of the choices and see what makes sense for this triangle before and after. Since I didn't specify what the triangle is, it should work for this. Excuse me. Okay, so let's take a look. First choice. AB is congruent to A prime, B prime. So they're asking if the size of AB changed. Well, let's take a look at our visual. Right now, AB, which is from 1, 1 to 1, 6, has a length of 5. A prime, B prime goes from -1 to -6. And again, it's a length of 5. Your figure just rotated. It didn't grow. It didn't shrink. So, of course, the before and after side lengths should be the same. So I'm going to say, yes, that's true. AB is congruent to the image A prime, B prime. Yes. The second one, the measure of angle C is equal to the measure of angle C prime. Well, that makes sense. C and C prime, those are before and after of the same angle. My angles didn't change here. My object just turned upside down, but it didn't change size, and my angles are never going to change size. So I'm going to say that yes, the second choice is correct. Third choice, the measure of angle A, P, A prime. Okay, so we're connecting A to P to A prime. Let me take a look. So A gets connected to P. Now remember what P is. P is that center of rotation, 0, 0. So A to P, and then A prime to P. So A, P, A prime. They're saying that this is a 90-degree angle, but it's a straight line. And we know that anytime you see a straight line, you have a straight angle. So the angle is not 90. It's actually 180 degrees. It's not 90. So A, P, A prime is not 90. It's 180, which is the same as the amount that we rotated. So we're going to say no to this third choice. Okay, so no. This shouldn't be 90. It should actually be 180. Let's take a look at the next one. B, P, B prime. Okay, let's go to our diagram. B, P, B prime. All right, so I'm going to connect B to P and P to B prime. So that's this little short line segment. Now again, if it's a straight line segment, that means it's a straight angle. So it's 180 degrees, which makes sense because if we rotate 180, then that means that you're going to form an 180 degree angle when you connect the before and after to your center of rotation. So this is correct according to our visual and according to our understanding of what a rotation is. So I'm going to go ahead and I'm going to select that yes, this is correct. Next one. Zoom out a little bit so I could see my graph and my choices. Okay, the measure of angle A plus B prime plus C prime equals 180. Well, we have B prime and C prime that are in our image triangle, and A is in our original. But what you should know is that angle measures don't change size, and they don't change degrees. So A and A prime are congruent. What we can do right now is we can think of angle A as angle A prime, since they're congruent. Now think about it. Look at your triangle. Do the three angles A prime, B prime, and C prime equal 180? And the answer is yes, they do, because any three angles of any triangle should add up to 180. So of course, A, B, and C should add up to 180. Absolutely. I like that choice. Let's go back. We're going to click off. Yes. The next one. The length of AP is congruent to the length of A prime P. Let's take a look. So AP, let me zoom out a little bit here. Okay, so from A to P, is it the same as from A prime to P? The answer is yes. When you rotate around a point, you don't grow away or closer to that point. You're just circling around it in this type of direction, making a circle. But you are not going further or closer to that center. So yes, from A to P should be the same length as from A prime to P. Get rid of that circle. So we're going to go ahead and say yes to this choice. Next, orientation is preserved after the rotation. Now let's talk about orientation. Orientation is how your object is lettered. So let's take a look at our visual and we'll talk about orientation that way. Notice right now, to go from A to B to C in my original red triangle, I'm going from A to B to C counterclockwise. CC, counterclockwise. Now to go from A prime to B prime to C prime after the rotation, let's see what direction we're going. So from A prime back to B prime, back to C prime. Again, notice we are going counterclockwise again. Orientation has not changed. Orientation would have changed if I had to go clockwise now to get from A to B to C. But since in both the before and after you're going counterclockwise when you're labeling from A to B to C, that means orientation has stayed the same. So we are going to go ahead and click off that yes, orientation is preserved after the rotation. The only transformation that doesn't preserve orientation is a reflection. So a reflection is your only transformation that changes orientation. Next, the perimeter of triangle ABC is equal to 1/2 the perimeter of A prime, B prime, C prime. Well, if the object does not change size, then your perimeter should not change. Perimeter means adding up all the side lengths. If the side lengths have not changed, your perimeter should not change. So I am not going to say that this one is correct. I disagree. The perimeters should be the same measurement before and after. Lastly, a reflection across the x-axis will carry triangle ABC onto A prime, B prime, C prime. Okay, well, let's pick one point. If I take point C, for example, and I reflect across the x-axis, so down one again, I end up here for C prime, which is at 5, -1. In my visual, C prime is all the way over here. So no, simply flipping this over the x-axis does not end up in the same place that a rotation of 180 would. So I'm not going to select the last choice. Now, one thing that you will note is that if you reflected over the x-axis and the y-axis, you would end up in the correct place. So taking a look at our first one, if we took C and we flipped over the x-axis, we're at 5, -1. And then if we flip over the y-axis, we're going to count to the left. 1, 2, 3, 4, 5. And again, 1, 2, 3, 4, 5. And now, yes, we would end up at all of the new image points. But they didn't say both x-axis and y-axis. They only said x-axis. So we're not going to say yes to the last choice. But we're going to put a little note for ourselves and say, if it said x-axis and y-axis, order doesn't matter, just if it had both, then that would be a yes. Okay, we are done with this question. Now, just to recap, if they're talking to you about some shape on a test, and they're saying it rotates some amount or it flexes some amount, but they don't give you information about that original shape, then it should work for any shape. So just make up a shape, follow the different steps through, and see if all of the choices make sense. Okay, let's keep moving. 163. If the coordinates of triangle ABC are A, 0, 2, B, 7, 4, and C, 5, 0, classify the triangle and select all that apply. Let's look at our choices. We have equilateral, which means all sides are congruent. 45, 45, 90, which is an isosceles right triangle. 30, 60, 90, which is a special type of right triangle, because again, we notice the 90. Scalene, which says all the side lengths are different, and isosceles, which says that 2 of the sides are the same. So just these 3 choices here, you're going to be able to figure out which of the 3 it is based on what the side lengths are. So our first step here is to figure out what are the lengths of the sides. Let's get some lengths. Let's figure out if any of them are the same, if they're equal. Now you need to go ahead and graph your triangle. So if you haven't yet, go ahead and graph it. I've already graphed mine. Now, if I want to figure out the length of each side, I'm going to take the shortcut if I'm on a graph. And the shortcut is to use the Pythagorean Theorem. So let's start with, for example, AB. If I want to find the length of AB, I'm going to draw my right triangle with it. So up and over. And now my 2 side lengths are 2. And horizontally, I have 7. So I'm going to use the Pythagorean Theorem with 2 and 7. AB is going to be 2 squared plus 7 squared equals C squared. 2 squared is 4 plus 49. We get 53 equals C squared. Square root both sides, and the square root of 53 equals C. I don't need a calculator. I'm going to keep it just like that and compare the other 2 side lengths. Okay, so now BC. I'll do that one next. Again, draw the little right triangle, and we have 2, and vertically we have 4. So now BC. 2 squared plus 4 squared equals C squared. 4 plus 16 is 20. So square root of 20 is C. So those 2 aren't the same, so it's not going to be equilateral, but let's keep going. Last one is AC. So for AC, down and over, I have 2, and horizontally I have 5. So let's do 2 squared plus 5 squared equals C squared. 4 plus 25 is 29. Square root both sides, so square root of 29 is equal to C. Okay, so these are our three side lengths. Since they're all different, square root of 29, square root of 20, square root of 53, if they're all different, the word for a triangle that has all the sides different lengths is called scalene. So I'm going to check off scalene. If it's scalene, it can't be isosceles. That means two are congruent. It can't be equilateral because that means all three are congruent. And now I still have two choices, 45, 45, 90 and 30, 60, 90. Well, a 45, 45, 90 requires that it's a right triangle because of the 90, but also that two sides are congruent because that's how you make two angles, 45 degrees and 45 degrees, congruent. Since I know this is not an isosceles, I don't have two sides congruent. I know it can't be a 45, 45, 90. But let's take a look to see if it's a 90-degree angle at all, or rather a 90-degree triangle, a right triangle at all. Now, the way that you figure out if it's a right triangle is by using our Pythagorean Theorem converse, which looks like this. C squared box A squared plus B squared. And we're going to use our three lengths that we came up with in order to see what type of triangle is it. Acute, obtuse, or in this case, is it a right triangle? So plugging in, C is your longest side out of the three, which for us is the square root of 53. That needs to be squared, because notice all of the side lengths should get squared. Box. A and B are your other two side lengths. So we have square root of 20 squared plus square root of 29 squared. Now for all of these, a square and a square root will cancel. So it's nice keeping it as a square root. We're left with 53 box 20 plus 29. So 53 box, simplifying further, 49. Now, since we are focusing in on this box, 53 is larger than 49. It's greater than. If it's greater than, then what you're looking at is an obtuse triangle. For it to be a right triangle, it would have to be equal. 53 and 53 on both sides, for example. So if it's equal, it's a right triangle. If the number on the left is less than the number on the right, then it's acute. Now we were looking to see, is this a right triangle? Because then maybe it's a 30, 60, 90. But it's not a right triangle. So that means we only have one correct choice here. All it is that it's a scalene triangle, and that's it. So only scalene. Okay, let's move on. Number 164. Find the value of the missing angle in the diagram below. So we're looking for the missing angle. Now I'm going to tell you now, this diagram, it's not drawn to scale. I did not make it drawn to scale. So let's go ahead and rely on the markings that we know in order to figure out our angle measure. Okay, I'm going to go ahead and I'm going to zoom in a bunch. All right, now let's focus. The goal of this question is to get this angle right here. That's my goal. Things that I notice. I have parallel lines. So I'm thinking about all those special parallel line theorems. Corresponding angles, alternate interior, same side interior. I'm thinking about all those different angles. Notice where I do have a measurement. I have a 74-degree angle down here. Now, if you look at it, that's not actually a 74-degree angle because it looks like an obtuse angle, and 74 is not an obtuse measurement. But this is where I made a mistake. I didn't make a great measurement. But we're just going to go with it. 74 degree is the measure of that bottom right angle, which means that this angle at the top, which corresponds to 74, is also going to be 74. So this entire red angle here is 74 degrees. Now, I don't have the green part that I want. I have the entire red angle, which is divided into two parts. So this whole thing here is 74, but I need the green part. So let's keep thinking. Now notice that we have a triangle coming off of this transversal. This triangle is not just any triangle. It's an isosceles triangle. And I noticed that because there's 2 tick marks there, which show me that the legs are congruent. So if this is an isosceles triangle, that means that the base angles, the ones across from the right angles, the ones across from the congruent sides, are themselves congruent. So this angle here and this angle here should have the same measurement. I can figure out what those measurements are. And that's going to be really helpful, because if I can know what this angle is, then I can subtract it from 74 to get my question mark. So let's go ahead and figure out what the measure is of those 2 base angles. Since in a triangle everything adds up to 180, I'm going to do 180 minus the 65-degree vertex. In my calculator, 180 minus 65. I'm left with 115 degrees for both angles together, the 2 congruent angles together. To find just one of them, I'm going to divide the 115 by 2 to figure out what each one is. So divided by 2 equals, I get 57.5 degrees. So that means that this angle here, this blue one that I just highlighted here, is 57.5. Let me zoom in. So this is 57.5. Since I want the green part, I'm going to have to subtract that 57.5 from 74 to see what's left over for the question mark. So now last step, 74 minus the 57.5. So in the calculator, 74 minus 57.5 equals, I'm left with 16.5 degrees for the question mark. And that's my final answer. So a couple of things you had to notice here. We had corresponding angles of the 74, those red angles, but the angle at the top, the 74, was actually split. And it wasn't bisected. It was not split evenly. So I had to figure out what this blue angle was, which was the 57.5. I had to figure that out by using my isosceles triangle that was right there in the middle, and figure out that if I subtract 65 from 180, I'm left with 115 for both angles. Divide that by 2, and I can get this measurement of 57.5. Then last step was to subtract that 57.5 from 74, and I'm left with 16.5 degrees for my question mark. Couple of steps here, but it's okay. Last question on this page. Let's move on. 165. Triangle ABC is transformed according to the rule xy becomes x plus 5, y minus 6. Okay, so a triangle was moved right 5, because that's why we add 5 to x, and down 6. Okay. Point A is at negative 7, 5 originally. And C prime, the new C, is at 4, negative 3. Okay, so they're giving us one coordinate from the before and one coordinate for after the translation. Okay, let's keep going. In triangle ABC, so your original triangle, 2 side lengths, AC and AB, are equal. With all that information, find the coordinates of point B. Okay, so let's think about what happened. We had a triangle. It was translated. They gave us a couple of coordinates. And in our triangle, we have 2 sides congruent, AC and AB. Both of the 2 sides have A in common, so that means A is at the top. C and B are the other 2 vertices. So my goal is to figure out where B could be so that the 2 sides are congruent in my shape. Okay, let's plot what we do have. So we do know that A is at negative 7, 5. So let me go ahead and plot that. Okay, so that's A. Now, they also give me C prime, but all the information that they tell me later is about my original triangle, AC and AB. All that's from my original triangle. In fact, I'm trying to figure out point B, which is from the original triangle. So even though they gave me C prime, let me go back and try to figure out C from the C prime. Now let's take a look. If C prime is at 4, -3, and I want to get back to C, what I'm going to do is I'm going to undo the transformation here. Instead of adding 5 and subtracting 6, to undo that and get back to C, I'm going to subtract 5 and add 6. 4 minus 5 is -1. -3 plus 6 is 3. So -1, 3 is my original C. Okay, let's take a look. I'm going to zoom in. So -1, 3 is my original C. Well, we talked before about how AC, which is this side length, is congruent or equal in length to AB. So I don't know where AB is, but it should be the same length. Like maybe B is over here, maybe B is over here. I don't know where B is. I just need to make sure that it's the same length as AC. Let me just fix this up a little bit. I erased a lot there, so let me fix that. -7, 4. That was here. That was A, and that was C. Okay, and connect them. Now, oh, let me fix it. It's at -7, 5. Okay, let me fix that one more. Okay, -7, 5 is here. There we go. Okay, now think about how you make things congruent. Things are congruent if they have the same length. Now, on a graph, how do we find length? Well, we use our Pythagorean theorem like this, and in our AC, we have 2. And horizontally, we're going from -7 to 1. So that's going to be 6. So we're looking at 2 squared plus 6 squared. And then that's going to give us our side length, our C squared. Well, what does that mean? That means if I go 2 and 6 in literally any other direction, then I'm going to come up with a congruent side. So let's think. I'm going to get rid of this. Starting at A, I'm going to figure out how can I go 2 and 6 in some other direction to get to a new point. Now, starting at A, maybe I want to go up 2, 1, 2, and right 6, 1, 2, 3, 4, 5, 6. Now I'm going to end up at a point B where AB and AC are the same because they have movements of 2 and 6. So my Pythagorean theorem will give them the same length. So that's one option. So thinking about closing up this triangle, here we go. Here's one triangle where AB and AC are equal. So one option for B is at -1, 7. That's not the only option, however. Remember, the key is you just go 2 and 6 in any direction you want so that you make the two sides congruent. So starting at A, maybe I want to go, let's say, down 6. So 1, 2, 3, 4, 5, 6. And go right 2, 1, 2. And then I'm going to put B here. Now again, if I connect A and B together, now I see another triangle here where again I have AB and AC as the same length. B can also be at -5, -1. In fact, there are many choices that you can have for B. As long as you have 2 and 6 as your movements, you're going to end up with a point for B that's going to make your triangle have AB and AC the same length. So right now I've given you two options. Let me write those down. Okay. So B could either be at -1, 7 or -5, -1. Those are the two that we've solved for so far. Now that completes page 33. We only have 2 more pages left. We can do this.